Hey guys, last time on 5.1 we talked about the antiderivative of some functions and indefinite integrals, right? So for example, if I give you something like f prime of x, like big F prime of x, equals to, I don't know, 2x plus 1. And I asked you guys to find the big F function. How do you do it? Well, what you're going to do is that you take the antiderivative of big F function, and that will give us like the regular f, right? So then the procedure how to do it, well, you're going to take the antiderivative of 2x plus 1 dx, and then you're going to split it out. In short, make a practice of yourself. If you were to have something like x squared plus x, then you did correctly. If you don't, make sure you talk to me before you continue to watch this video. Okay, and then on top of that, I put in pink in the last section. If I were to give you some I don't know, initial condition, something like if f of 1 equals to, I don't know, like 5, then you have to give me some particular solution, right? And how do we do it? Well, we're gonna set all of this equal to 5, and then we plug in 1 wherever we have x, right? So it goes like this, and if you do it correctly, c in here equals to 3, right? So then the f function here, or the particular solution, it looks like f of x equals x squared plus x plus 3. Okay, and this is what I'm looking for. Okay, so make sure in the test you remember like step by step which one to do first, and then how to use an initial condition function. Okay, so let's talk about today work. Before we jump into the content, here's some review. We have this table in the last worksheet or the last section, but make sure you remember these rules. And I told you guys the things are the most important to me in here are the constant rule and also the power rule. So make sure you remember them and you remember how to apply them. Okay, but as you can see, like we apply all 4 rules in here in each of the integral problems, right? So make sure you understand and know how to use each of them. Okay. So in last section 5.1, we use a simple power rule, this one in here, to find the antiderivatives of function expressed as power of x alone, such as x squared plus 1 dx and so on, right? However, if the problem is something like ugly as this one, right? Like where you don't have just x, and then there's no way that you can split these out, right? How can we integrate this function? So this one is supposed to be integrate, not integral. There's a typo in here. Let me just rewrite this whole word here. How can we integrate this function? In this section, we will study a technique for finding antiderivatives of more complicated functions. And really soon, you will see U substitution. And it's just, like spoiler. But warm up, know that the constant multiple rule, it is legal to do the integral of this function equals to, like, pull out a 2 in here, and then we're just going to have the rest of the integral on the inside of the integral. But it's not legal to do this, right? Like we can pull out a 2 because it's a constant, but we cannot pull out the x because x is not a constant. Okay, so let me backtrack all of this, and then let me draw an arrow on this one. The 2 pull out, this one is acceptable, but for the x to be pulled out, this one is not acceptable. And why is that so, right? Like, is there any reason why we cannot do it? Well, there is, right? Because x in here is not a constant, okay? And then the derivative, like this derivative, this integral and this integral, they're gonna give you like different answer, okay? We don't know the technique on how to solve them yet, so I cannot like show you guys like what answers of each of them, and then we cannot compare the answers. But trust me, the answers for these two are not equal to each other. Why is that so? Because x in here is a variable, it's not a constant. Okay, so x is a variable, that's why we cannot pull it out. And then 2 in here is a constant, that's why we can pull it out. And this is my t. Okay, so moving on to the next objective of today, substitution. As I told you guys from the last page, we would use substitution or change of variables to completely rewrite the integral in terms of u and du. That is, originally we're going to let u equals to something like some function you will see very soon, and then we'll take the derivative of it. Okay, In general, we're gonna have this formula in here. Trust me, like it doesn't really make sense when we first look at the formula, but after you do like a couple of examples, it will start to make more sense. Okay, at least that's me. Okay, so I'm not gonna explain this formula to you guys yet, but then just wait until you see my first example on my side, and then let's get back to that formula later. Okay. So for my example, we have two parts in here, right? We have the x and we have the integral, right? So which one is more complicated in here? I hope everyone agrees with me that the integral, like the square root, is more complicating, right? It's more complicated, of course. So then in that case, I'm gonna let u equal to the function on the inside of the square root, that is 3x squared plus 1, okay? After I finish my u sub, I'm gonna take the derivative of it. And then hopefully everyone knows how to do this one. This is 6x, right? And after that, I'm gonna go ahead and solve for my, oh, by the way, okay, this is the thing I always forget, okay? So make sure you always have like two differentials on both sides, okay? When you take the derivative of it. In the past, we just do it like, you know, like y prime equal to something and prime equal to something, right? But make sure for like this section on, when you take the derivative of two sides, that means that you have to do differentials of two sides, okay? So then when you take the derivative of u, you write du. When you take the derivative of x, you write dx, okay? And why is it important? Because on the next step, well, you have to solve for dx, okay? And then here's pretty simple. We're just gonna go ahead and divide everything by 6x, okay? And if you want me to label it, first step, you have to call your u to be an inside function of something like more complicating. Second step, you have to take the derivative of du, and then third step, you have to solve for dx. Okay? Okay, so that's all about u substitution, and now step 4, plugging everything that we have into the integral. And what do I mean by integral? I mean this one in here. So we start by having the integral, and x is just x. We don't know anything about x yet. And then we have the square root on the inside for 3x squared plus 1. We're going to have a u. And instead of dx, we're going to have du divided by 6x. Okay, so let me go ahead and get rid of these. So then just to confirm about like the things that we have, this is what I mean by square root of u. And this is what I have for dx. And why is that so? Because of this substitution in here. Okay, and the green one, if you want to look back at step 1, there they are. Okay. And now what do we do? Let me put in orange. Okay, I'm gonna go ahead and cancel the x's in here because I can do that, right? And then the 6 in here is a constant, so I'm gonna go ahead and pull it on the outside. But remember, because 6 is on the bottom, so when you pull it on the outside, it still has to stay on the bottom, right? Because if you were to write it like just a 6 in here, then it doesn't make sense. Because this 6 is on the bottom, and this 6 is like just, you know, doesn't even have a fraction to be on the bottom, right? So you will know right away that there's something wrong with the 6 in there. Okay, so pull the 6 outside. I'm gonna get 1 over 6. And what do I have in here? I'm gonna rewrite my u to be u to the 1/2 power, and then I have du in here because we're talking about the u variable, not the x variable anymore, right? And after that, I'm gonna go ahead and take the integral of this thing. So let me put it in I don't know, brown. So this is step 5 where we take the integral. So then this equals to 1 over 6 times u to the 1/2 plus 1 divided by 1/2 plus 1, right? And then plus c at the end because we losing the integral. And then in short, this is 3/2, right? So if you were to put it into the calculator, 1 over 6 divided by 3 over 2, I'm gonna get something like 1 over 9. And then for the u, I'm going to get something like 3/2 in here. And then plus c, right? And then we all know how to change this thing to the root form. So I'm going to go ahead and change it to square root of u cubed at the end because we start with the problem with x, right? So then the answer in here, we have to switch it back to x. So let me put it in running out color. Let me use green. So this is step 6, okay, where I put everything in terms of x. So it's gonna look like 1 over 9, and then square root of, what is my u? This is my u, right? So I'm gonna get open parenthesis 3x squared plus 1 to the 3rd power plus c. And this is my complete answer. Okay, for your part, you have to do this problem right here. Okay, and here's the guideline of like how to do it step by step. Okay, I had like one more, or I should say like 2 steps ahead, but make sure you know the big like key point here from step 1 to step 4. Those are like really important points in here to focus on, and you're gonna see them in the test in the explanation part. So make sure you know like which one came from where. Okay, and talk about this formula right here as I promised. Well, if you notice, you can understand like the dx in here canceled out, and then you end up having just u to the n power and then du. Okay, that's what actually going on in here, because as you can see, we start with both x and u, but at the end some x's will be canceled out and we only left with u's, and then it's easier to work with one variable, right? So this is the whole goal for it. Okay, and now let's talk about the other objective, extended application propensity to consume. So I don't, oh yeah, this one, yeah, you're gonna see this one on a test too, but it's similar. It's like a similar procedure to what we did in the past. So we're gonna have some like initial condition, let me highlight in pink again, and then we're gonna have some function to take integral of, right? Okay, so as for the knowledge in here, as the income increases, the ratio of consumption to savings tend to decrease. The rate of change of consumption with respect to income is called the marginal propensity to consume. I'm not really sure if I'm going to test you on the terms in here, but this one, you know, like in terms of business, I guess it makes some sense, but in terms of math, it's just, you know, like definition. So I'm not going to go in depth about that. Okay, but if you do have questions about this definition of marginal propensity to consume, let me know, okay? I can definitely find more example on that, on, you know, like real application. Okay, so right now, let's solve for C first. And notice that originally we start with the derivative of C, right? But then we're solving for C by taking the integral of the given function. Okay, wait, let me put it in red actually, because that's how we usually do it. So C in here equals to the integral of the function given by the problem, and then dx, because they go in pair with the integral. Right, and as you can see, we don't have just like x to the something, right? We have like this weird, ugly thing. So what do? Well, we have to do u substitution, right? So let me put it in blue. First step, call u for the inside. So I'm going to have u equals to x plus 1 in here. And second step, taking the derivative of both sides. So on the left-hand side, I'm going to have du. On the right-hand side, the derivative of x is 1. The derivative of 1 is 0. So eventually, I'm just going to have 1. And then because we're taking the derivative with respect to x on the right side, we're just going to have dx, right? So it means that we have du equal to dx, because 1 times dx is just going to be just dx, right? And then step 3, we're solving for dx, right? And then it's already there, right? So we don't have to solve for it anymore. Dx equal to du if you want to like write down in this step-by-step procedure, okay? And now, let's change the color first. So step 4, we're going to go ahead and plug in everything from the original problem to it. So I'm going to have the integral of 4 on the top part and then squared. And then on the inside, I will have my u in replace for x plus 1 or vice versa. So I'm going to have a u in here. And then for dx, I'm going to get du, right? And if you don't know why, let me put it in pink. This dx in here equals to du, because, well, they're the same thing, right? And then this one in here is this one in here, okay? And then what do I do after this? Well, I'm going to do it out, right? So I'm going to pull out the the constant in here, and that leaves me with 1 over square root of u, and then du, and then I change it to integral of u to the negative 1/2, because then my u's on the bottom. And then step 5, let me take the integral of it. So let me do it in pink, I guess. Okay, 4 is just 4, right? But then the integral of this one, skip forward, I'm going to have u to the negative 1/2 plus 1, and then divided by the same power, negative 1/2 plus 1, and then plus c to compromise for the missing of the integral and du, right? And this in here equals to 1/2. So if you flip it and you multiply with 4, you're going to get 8. And then the new power in here would be 1/2 and then c, right? And then I personally don't like it in the power form, so let me go ahead and switch it back to the root form, which gives me 8 square root of u plus c. And then last step, we switch everything back to x. So let me put it in brown, I guess. So step 6, define the answer in here. Or, okay, it's not going to be the final answer because we do have some like initial condition and we haven't got to that yet, right? So my c function in here equals to 8 square root of u plus c. Okay, and you're going to ask me, well, there's 2 c's, right? Like there's one c in here and then another c in here. Are they the same thing? Are they different? What do they mean, right? And I'm going to tell you the c in here is for the constant. Okay, like the constant that we always going to have for whenever we take the antiderivative. And the c in here is for the cos. Okay, so to make sure you know which one is which, let me actually put c of x in here. Because in the test, you're going to have like 2 c's in here. Like one for the cos and the other one for the constant. So you have to know which one is the cos and which one is the function. Okay, so this in here is the cos. And then this in here is the constant. Okay, and usually to make the difference between the two of them, for the cos function, because it's a function, I'm going to write a variable x here to show that it's a function. Okay, but then in real application, especially when you have like the initial condition in here, that's not the end, right? So let's go ahead and talk about step, I don't know, 7 in here. This is the best color I can have in here, in orange. Hopefully it doesn't like, you know, too bright. It's not too bright. Anyway, so what do we do with this condition, right? First of all, let's rewrite it, right? So I'm gonna have something like c of 15 equals to 50. And what do I do? Well, I'm gonna go ahead and replace 50 with this whole thing in here. So I'm gonna get something like a and then square root of u. But wait, should I plug in 15 right away or no? The answer is no. Don't do it, okay? I purposely done it like all the way to here so that I can show you guys that this is a mistake, okay? So let me go back in here and show you guys why it's a mistake. In here in step 6, this is not like the good answer for step 6 because we want the x variable, right? We don't want a u variable. So that means that we have to switch it back into x. And our u in here is x plus 1. So let me go ahead and replace u by x plus 1. And then I'm going to have a plus c in here, right? And then we're going to go ahead and use this function for step 7. Okay, so then it looks like x plus 1, where x equal to 15. That means we're going to have like 15 plus 1 on the inside. Okay, so if you notice in here, if you were to go ahead and plug in 15 directly at this equation, you're not going to get a nice answer. And on top of that, you're not going to get the right answer because this in here is the x, not u. Okay, 15 in here is meant for x, not u. So make sure at step 6, whenever you're done integrating it, make sure you solve for x, or like make sure you have x as a variable. Okay, if you still have u there, that means you did it wrong, or that means that you're missing a step of plugging back x into your function. Okay, and lastly, how can we solve for c in here? So if you were to put it in a calculator, let me do it step by step again. So on the left hand side, we're still gonna have 50, and then on the right hand side, this is 32, and then plus c. So then my c equals to, what is it, 18? So then my final answer, cos function in here, it equals to 8 square root of x plus 1 plus 18. And let me rewrite my one really quick because it looks ugly. And this is what I'm looking for. Okay, and here's what you have to do for your part. Okay, so for your part, it's similar to what I had in here. You have a function to integrate, and your function will be the x function, okay, because x is on the top, and your variable in this case would be p. Okay, it's like a little bit confusing for, you know, like which variable to use, but yeah, it will make sense when it comes to, you know, like whatever you have on the function. And then just a heads up for the initial condition. So for these piece of information in here, if you were to have something like what is it, x, what's the price in here, 13 equals to 600, then you're right. Okay, but if you were to get something like x of 600 equals to 13. That's wrong. Okay, so make sure you don't do it like this. And how do I know which one is which? Well, I base it on this. Okay, so for the inside, like whatever inside the parentheses, it must be the price. And the price in here is obviously 13, right? So the 13, it has to stay on the inside of the parentheses. Okay, so make sure you don't do this in the test. So this is your initial condition, and after you finish like integrating your equation or your function, you're gonna need to plug it back into this initial function in here, and then after that you're gonna be solving for the supply function in x. Okay, so if you have any question on that one, let me know. Thank you for your listening. Take care and have a great day. Bye bye.